Hey everyone, it's Mr. Anderson coming to you again with section 10.2.2 from our CPM Common Core Algebra book. And today we're going to look at, again, rewriting specifically for the purpose of eliminating rational expressions. Our CPM authors call this fraction busters, and if you like that name, great, but really what it means is when we're faced with an equation or an expression where we have a denominator, where we have a fraction, where we have a rational expression, we are going to try to make our lives easier by getting rid of that denominator. We're going to start with some modified notes here. And I have problem 10-34 from section 10.2.2. And if you're looking for this in our text, you are going to mouse over 10.2.2. You're going to find problem 10-34. It is the first problem from this particular section. And we start with an equation, and we are asked in part A to multiply each term by 6. Okay, so that's where I'm going to start. I'm going to go ahead, I'm going to multiply this by 6. I'm going to multiply this by 6, and I'm going to multiply this by 6. And I'm going to take a second to rewrite it. Now, I recognize that multiplying something with a denominator, multiplying something by 6 with a denominator of 6, like I've done in this first term, the 6's are going to cancel. So I'm going to have an x right there. And then right over here, I'm going to have 6 times 5, which is 30 over 8. Now I'm going to simplify that in just a second. Give me just a moment to do so. And then I've got 4 times 6, which is 24. Okay? Now I could technically go ahead and work with that, but I'm going to, like I said, simplify it, and we're going to talk about the result after I simplify. I'm specifically going to simplify for what I see right here, 30 over 8. I recognize that both of those things have a factor of 2 that goes into them. 30 is divisible by 2, 8 is divisible by 2. I'm going to rip out that least common factor, that greatest common factor, and I'm going to rewrite that as 15 over 4. If you're not sure what I'm doing there, right, I'm taking this and dividing by 2, I'm taking this and dividing by 2, and just rewriting that fraction. And if this is something you recall from an earlier course, bravo, but if it's not, we've got to ask. I do only have to do it to that term because dividing top and bottom by 2 is really just another way to divide by 1. And because 1 is our multiplicative identity, I'm allowed to multiply and divide by that without consequence. Now look at what the heck I have here, right? And this is what part A is leading me into. It says, hey, do any fractions remain? And the answer is absolutely fractions remain. I've got a fraction in that second term. Okay, I've got a fraction 15 over 4. 4 does not go evenly into 15. I know that because 4 goes evenly into 16, and there are no consecutive integers with common factors, right? So like 15 and 16 don't have a common factor of 4. So I can't divide 15 evenly by 4. Well, golly gee, now what in the heck do I do? Well, that's what part B is going to lead me to. It says, if you haven't already done so, decide how you can change your result from part A so that no fractions remain, and then solve the resulting equation. So what we're going to go ahead and do here is I'm going to take a tip from part A, and I'm going to multiply by something to get rid of that denominator. I'm going to multiply this thing by 4 to get rid of that denominator. Now, if I do that, because I'm not multiplying top and bottom by 4, I have to multiply everything by 4. All right, and when I go ahead and do that, I end up with, and I'll write it over here, 4 times x is 4x. 15 fourths times 4, these cancel, so it's going to be minus 15. And then 4 times 24, this works out to be 96. Okay, now that is going to be one of those, that is a simple two-step equation. I can go ahead and solve this thing by adding 15 to both sides. 15, and now I have 4x, and that's equal to, let's see, it's going to be 111. All right, and now I'm going to divide both of these by 4, and 111 divided by 4, I believe, is 27 and 27.75. All right, pretty sure that math works out. Yes, it does. Okay, so we can solve doing that, and by multiplying those two steps, look at what the the easier equation was that I was able to work with. All right, yeah, I know my answer was a decimal. We're not always going to have integer answers. That's okay. Okay, but let's talk about this. It says in C, multiplying our original equation by 6 did not eliminate all the fractions. What could you have multiplied to get rid of by all the fractions, or to get rid of all the fractions? Well, I had to multiply 6 and I had to multiply by 4. And that's because I effectively, when I multiplied by 6 and by 4, I effectively multiplied everything by 24. Now, why is that significant? All right? That's significant because it is the least common multiple of 6 and 8. All right? If you were to go ahead and list out 6, 12, 18, 24, 30, right? All the multiples of 6. Do the same thing for 8. 8, 16, 24, 32, 40. Notice that they have 24 as a least common multiple. Okay? And that 24 connects to the multiplication of 6 and 4. So if you can go ahead and find, when those denominators don't match, if you can go ahead and find the least common multiple, it really is going to make your life a ton easier. I promise you, you could go ahead and take this and start over. I'll just rewrite it. I'm not going to do it again, but you could take this, and if you wanted to start over, this is the original, you could multiply each term by 24, and you'd end up with what we ended up with. 4x minus 15 equals 96, and you could solve and get 27.75. That would work out really, really nicely for you. Okay, we're going to take this idea, we're going to put it into some practice, again, for the purposes of rewriting and making us more effective problem solvers. I've got another problem set up here with a kind of a similar take here. Work with your team. We obviously don't have a team. We're in this digital setting here. To solve each of the equations below, first by finding an equivalent equation that contains no fraction. Each problem represents new challenges and new situations. Be ready to justify how you solved each problem and share why you did what you did with the class. Remember to check the solution. Well, I'm going to start with A, and I'm just going to have to do some rewriting here. I've got x over 4, I've got x over 6, and then I've got 2/3. Well, I recognize that if I get rid of the 6, I'm going to get rid of the 3, because 3 goes into 6, right? 3 is a factor of 6. But if I get rid of the 4, that's not going to get rid of the 6 necessarily, and it's not going to get rid of the 3, because 4 is not a factor of 6, or 3 is not a factor of 4, etc. So I'm really looking for something that 4, 6, and 3 all go into. Now, the 6 and the 3 is maybe cheating a little bit, because if I list these out, 3, 6, 9, 12, right? These are going to have a common factor that's pretty obvious, pretty gosh darn quick. Okay, you guys see that they both contain 12. Okay, but that's actually also really convenient for my 4, right? If I list out my common multiples of 4, you can see that multiplying everything by 12 here really should do a great job of getting rid of all of my fractions. Okay, and when we multiply, we're really, like, let's be honest, we're multiplying by 12 over 1. Okay, but I'm not going to write it as over 1. I'm just going to write it as multiplication on top, and I'm going to do the division. All right, so multiplying by 12 gives me 12x over 4, and 12 divided by 4, that turns this into a 3x. Multiplying by 12 gives me 12x over 6. I take 12 and divide it by 6, and that's minus 2x. And then multiplying by 12 gives me 24, and 24 over 3 is 8. Now I can just go ahead and do this subtraction. 3x minus 2x is 1x, and 1x is 8. And you know what? Let me just do this rewrite step just in case you're wondering. This is 12x over 4, and this is 12x over 6, and this is finally 24 over 3. And that's where the division comes in handy, right? 12 divided by 4 is 3, 12 divided by 6 is 2, and 24 divided by 3 is 8. Okay? And then I just do the subtraction. That's part A. Let's keep going with part B. Part B is a really gosh darn interesting problem, because we don't have a number in the denominator, but we have an x in the denominator. Oh no, it's actually not too bad. Okay, it's really really manageable. We're going to follow the exact same process. I'll rewrite b down here. I've got 5 divided by x minus 2x, and that's equal to 3. I recognize my x in the denominator, so what I want to do to cancel that is I want to multiply everything by x. So I want to multiply that 5 by x, I want to multiply this 2x by x, and I want to multiply this 3 by x. Remember, I'm doing it to everything on both sides. Okay, so 5x and x cancel. That's good. That's good for me. It does what I wanted it to do. I've got a 5 minus 2x times x is 2x squared, and that's equal to 3x. Now, this is going to be a quadratic, and the quadratic is going to be a, what's it called? Something that's solved via factoring or via graphing or via the quadratic formula, right? I don't necessarily know that this one's going to be factorable, but we'll do a little bit of work here. I'm going to bring this 3x over and switch the side, switch the sign. I'm also going to write this in standard form. All right, and now, ladies and gentlemen, I can go ahead here and just maybe to make my life a little bit easier, I'm going to switch the sign on everything, right? 2x squared plus 3x minus 5 equals 0. I'm allowed to do that. Obviously, I'm not switching the sign on 0, but now I could go ahead and I could say a is 2, I could say b is 3, I could say c is negative 5, and I could use the quadratic formula to solve this here. In fact, that's what I'm going to challenge you to do. I'm going to pause the video, I'm going to work this out with the quadratic formula, and I'm going to challenge you to pause the video, and we'll come back together in a second here, and we will identify those solutions. Okay, there you go. You can see that I identified A, B, and C, and I worked this out using the quadratic formula. How did you do? I had two solutions there. I've got x equals 1, and I've got x equals negative 2.5, right? Check those items out. We're going to take care of one more of these because it is a fairly interesting problem, and it's going to be letter C. So the next one I'm going to do is going to be this one, but I need to give myself a little bit more space for the purposes of doing this problem. So I'm going to try to zoom in right here, but before I do that, I'm going to rewrite this in purple, okay? So I've got negative 2x plus 1 over 3 minus x plus 3 over 7, and that's equal to 8. So let's tackle this one, all right? And here's where I can really save myself a little bit of time and multiply by that least common multiple. So I recognize that 7 and 3 are my two denominators here. And I can, let's see, 7 doesn't go into 3, 3 doesn't go into 7 evenly. So the least common multiple of those two things is going to be 21. So I'm going to go ahead and take 21 and I'm going to multiply on the top and bottom by 21. I'm sorry, on the top, on both these terms, okay? All right, and if I do this, ladies and gents, something kind of interesting happens, okay? I'm going to cancel this 3, but when I cancel a 3 from the 21, I'm left with the 7. Now, can you predict where that comes from? I'm going to cancel this, and I'm going to cancel a factor of 7 from the 21, and when I do so, I'm left with 3. So really, this problem becomes 7 times negative 2x plus 1 minus 3 times x plus 3, and that's equal to 8 times 21. Okay, so simplifying my problem really was a pretty easy thing to do there, but you know, I got to remember some of those multiplication facts. I've got to remember some of those ways that I multiply and divide. And now it's time to distribute and really kind of combine some like terms, and you guys can recall the distributive property here. So this is going to be negative 14x minus, plus 7. And then minus 3x, and then minus, I'm doing this right here now, minus 3 times 3, which is 9, and that's equal to 8 times 21, which is, I believe, 168. Okay, now it's time to combine those like terms, and I have negative 17x, and this, I believe, works out to be, when I combine the 7 and the negative 9, minus 2, and that's equal to 168. Now, this should work out pretty nicely for me. I'm going to add 2 to both sides. Negative 17x equals 168, and 2 makes 170. Holy cow, this is going to work out really nicely. Let's divide both sides by negative 17, and my answer works out to be negative 10. All right, we could check that solution, but ladies and gents, I promise it's going to work out. There is a tiny bit of review preview here. let's go ahead and be trying these things and asking the questions, following through with the questions that come up. Ladies and gentlemen, thanks for watching. Have a great day.